Well, hello, you two. I hope all is well. It's been a long time. Hopefully, we can get back to school here soon and get some normalcy going again. I think that would be good for everyone. Take some minds away off of some other things that are happening. But we'll go ahead and get started here. We're going to do lesson 84 today, okay? And then that is selecting an appropriate rational number. And what that means is really just, hey, it wants you to choose the correct method or the appropriate method for should you be using a fraction, should you be using a decimal version, or maybe should you even be using a percent, okay? And then that's what we need to figure out here today. So we're going to jump right in. We're going to go through example 1. I'll put it on the board, okay, and go from there. So how much is 40% of a half of 1260? So I'm not going to write, actually I'll write this whole thing out so you can kind of see. Okay, how much is, I want to show you what this means. How much is 40% of 1/2 of 1260? So, well, how much we don't know. So I'm going to write this now how it should look a little bit nicer, okay? A little bit more appropriate so it doesn't look so confusing. How much? That's the question mark. We don't know. Is, remember, is always means equals. So equals. We're looking for the answer. 40%. Now, I could leave that as 40, but if I was going to rewrite that, you need to rewrite that as, you could rewrite it as a fraction, which is 4/10. Or you could rewrite it as a decimal, which is 0.4. In this case, since I do have a fraction right here, and what does of mean? Of means multiply, okay? So, and it always means multiply. So because I have a fraction right here in 1/2, I'm going to just make this a fraction, and then I'm going to multiply those two. And then at the very end, I'll multiply it times 1260, okay? So here we go. We have, and really, probably the better way since we have a decimal at the end. In all honesty, I kind of told you a little bit goofy, but since we have a decimal at the end, we should probably just convert them all to decimals. That might make it the easiest. Then we only have to change them once. So let's do that. I apologize, okay? So let's change the 40% to a decimal. And how do we do that? We move where the decimal would be, you move it 2 spots back, and it would say 0.4, okay? Well, what is a half? What decimal is that? That's going to be 0.5. Okay, and then at the very end, you have 12.6. If you want to put the 0, you can. It's to me, it's not needed. It's a waste of a number, especially when the zero's at the end, so I don't like to include it. I just will remember that, hey, don't forget, this is money we're talking about. So at the very end, obviously, no one sees price tags like this. They don't say, oh, 12.6. No, it would say $12.60. So make sure at the end you do add that back on, okay? Let's start with the first ones. It's literally 0.4 times 0.5. Okay, so I'm going to start right here. 0.4 times 0.5. Well, it's just 4 times 5, which is 20. Now, don't forget about these decimals. How many decimals did we move? We have a decimal here, and then there is one number after it and another number after it. So there's 2 numbers after our decimals. There's our first one, there's our second one. So then that means that we come back here and we start at the very far right side and we go 1 decimal place in and another decimal place in, and that's where it should be. So it should be 0.20. Okay, 0.20. Now we are going to take that 0.20, or what I'm going to say is, remember I get rid of this 0, I'm just going to say 0.2. We're going to take that 0.2, okay, and we're now going to multiply it by 12.6 times 0.2. Okay? And again, you just treat this like a normal, just like a normal multiplication problem. This could just be like 126 times 2. It's the same thing. The decimals We'll count at the end, okay? We'll count at the end. So what we should be doing is taking 2 times 6, that's 12. Carry the 1. 2 times 2 is 4, plus 1 is 5. We don't need to carry anything. And then 2 times 1 is just 2. Okay, so if we took 126 times 2, we should get an answer of 252. Obviously, we didn't do that. We took 12.6 times 0.2. So don't forget about that. Now we need to see how many decimals are to the right. How many numbers are to the right of our decimals in our normal problem? If you look up here, I see a decimal right here. How many numbers are to the right? Just 1. Are there any more decimals? Yes, there is. There's another one right here. How many numbers to the right? Another 1. Well, one number, that's going to be 2 total, so you're going to have to move the decimal. So you start at the far right, and you go 1 move in, and another move in, and that's where the decimal should go. And it should be 2.52. Okay, so I hope that one helped a little bit. And again, it wouldn't have been wrong if we would have converted this to a fraction and left that as a fraction. It's just at the very end, we would have had to switch this back. It's at the end of the world, absolutely not. This lesson's just trying to get you to recognize, should I change it to a decimal first, or should I change it to a fraction first, or maybe should I change it to a percent? Okay, it's just making sure that, hey, maybe you're thinking about the whole picture here. Okay, again, one more thing, don't forget, is means equals, and of means times, okay? So I'll get out of the way so you can just kind of see that for a second. We will do example B, we'll do 1B from example 1 next. Okay. Okay. So, now B, how much is, I'm just going to write question mark this time. I'm not going to write the whole thing. How much, we don't know. Question mark is equals, how much is, and then I'm going to write this normal first. 66 2/3%. 66 2/3%. And then of, what does of mean? Of means times. So there's a times sign. 5/6. Just going to write 5/6. And then I'm going to write 1260 again. After of, we have another of, which is another times, and I'm going to write 12.60. Remember, you don't need the really zero at the end. If you want to throw it in there, you can. That's up to you. Obviously, it's money again, so make sure at the end of your answer, make sure you do put that in there, okay? And we'll go from there. So, it's trying to get you to select appropriate terms, okay? Now, we have this one is a percent, this one is a fraction, and this one's just a normal decimal number, okay? I say we convert these all, like the first 2 numbers to fractions, okay? You could convert this to a decimal. It's just this decimal is 0.6, and then it repeats. So, like, there's just, a million sixes after it. Well, in order to make that more accurate, so we don't have to write 0.6, 20,000 times, we're just going to leave it as, what percent is 66 2/3? Well, it's actually just 2/3. That's the fraction it's for. Okay, so it's 2/3 times 5/6. And then I could write this at the end. I'm going to do this math problem first. I'm going to get that answer, and then I'm going to take it back up to the 1260, and we'll do it, okay? So, here we go, right? As I look at this, I see, hey, there's 2 numbers that we can reduce. And how you do that is you always look at the numbers diagonally from each other. Okay? And you ask yourself, hey, do those numbers have a multiple in common? So, like, let's look at the 3 and the 5. Do the 3 and the 5, do they have a multiple in common? Like, besides number 1? 1 is not going to change anything for us to reduce by, but 2, no, that doesn't go into 2, or that doesn't go into 3 or 5 evenly. And the only other number to choose from is 3. Well, 3 goes into 5, but not evenly, so we can't reduce it. So they have no multiples in common, okay? The 2 and the 6, however, though, they do, okay? And what multiple do they have in common? Well, they have the number 2. Could you say 3? Well, no, because 3 doesn't go into 2, okay? It does go into 6, but not into 2. 2 goes into 2, and it also goes into 6. So that's why we're using the multiple of 2, okay? How many times does 2, I'm crossing this off because the number is going to change. How many times does 2 go into 2? 1. How many times does 2 go into 6? And that's going to be 3. And now we can start multiplying this. Remember, when you multiply fractions, we do top times top and bottom times bottom, which is 1 times 5. Okay? And then obviously we do the bottom. And it's 3 times 3. That's our new number down there. And that's going to be 9. Okay? Now, again, that's not our final answer because what did the original problem want us to do? It wanted us to take this times this fraction times 1260. Okay? So now, I have 5 over 9, and I'm going to take it times 1260. Let's write that over here. So you can see what is obviously weird about that. Can we do that? Okay, well, we actually can do that. Okay, so what we're going to do, okay, is we're going to take this 1260 and we're going to divide it by this bottom number over here, this 9, okay? And that's how we're going to start. So we're going to take 12.6, 1260, and divide it by 9 because that's the bottom number. And bear with me, I know this will start here. This will make sense in a second, okay? How many times is 9 going to 12, which is 1? There's 3 left over. Don't forget about the decimal. And then obviously bring the 6 down. How many times does 9 go into 36? 4. You're saying, well, 1.4. Okay, that doesn't make much sense. Well, we just figured out, okay, hey, if I broke down the 1260 divided by 9, I got 1.4, or $1.40. We divided it into 9 groups. Now, to figure out the rest of this, right, we need to divide by the number we didn't use. Or, I'm sorry, not divide by the number we didn't use. We need to times by the number we did not use yet, which we did not use the 5. Okay, so we're going to take 1.4, or $1.40, and we're going to times it by 5. 1.4 times 5. It's the same as taking 14 times 5. We just have to move the decimal at the end. 5 times 4 is 20. 5 times 1 is 5. Plus 2 is 7. Now, how many times should I move the decimal? There's only one number to the right of this decimal, so I'm going to move it once. 7.0. 7.0. But again, what I always tell you, I get rid of the zeros and I put them on at the end if it's needed. Now, is this one needed? Well, yes, it is, because why? Our final answer should be a dollar form, right? And I've never walked up to a price tag and been like, oh, here's the price of this shirt, 7.0. This doesn't make sense. That's not how the stores do it, okay? What you're going to see is 7.00, $7. Okay, so don't forget to put that in there, 7.00, and the dollar sign, and there you go. Okay. So again, backtrack here. We converted these both to fractions. We multiplied them. We got 5 over 9. We knew we had to take it times 1260, so I brought that over here. I lined it up. It looks weird. What do we do right away? 1260, 12.6 divided by 9. Okay, we divided it out. We got 1.4 or $1.40, depending on which one you need to use. I didn't want to, so I brought it up over here, 1.4, and now we need to times it by the number we have not used, the 5. Well, got 7.0. Remember, we were talking about money, so it's not 7.0, it's $7. Okay, I'll kind of get out of the way, and we'll kind of go from there. I'm not going to put this next one on the board. I'm going to erase this just so it doesn't look like a big cluster. Okay, I'm just going to read this one, and what this example 2 is really about. It wants you to pick which choice A, choice B, or choice C would be the appropriate way to display this. Okay, and when you read it, you'll start to see it and you'll make sense, right? It says, in a public opinion survey, 180 of the 280 women surveyed agree strongly with the mayor. So I'll write that on the board just so you see it. 180 over 280. This was talking about women, so I'm going to make a little note, okay? And then I'm just going to put they agreed strongly. That's what it said, just so I know, okay? And then let's just keep reading on. While 150 of the 275 men, so 150 of the 275 men that were surveyed strongly agree with the mayor. So I'm going to put that again. SA, strongly agree. Strongly agree. You might want to put it that way. Okay? So, which choice listed below is the most appropriate way to decide the results of the survey? Well, when you see surveys or results presented from a survey, do they list it like this right away? You know, 150 out of 275 men, they don't really list it like that. They always usually list it in terms of percents. Hey, 20% agree. Hey, 42% don't agree, or whatever it may be. It's always in terms of percents because it's just more universal percents. You know, it's normally out of 100, and people can associate with a percent number better normally, in my opinion, than a big fraction number like that and telling them, hey, the whole data part of it. So the first one, letter A, 9/14 of the women and 6/11 of the men agree with the mayor. I mean, that's just something you don't hear of on the TV, right? Or anywhere when they're talking about, like I said, someone took a survey. It's usually always in percent. So they also don't say, like letter B, 0.643 of the women. So I'll write that over here. 0.643 of the women and 0.545 of the men strongly agree with the mayor. They don't write it like that, even though, I mean, it's the same. It's a little bit better than writing it as opposed to fractions, because this technically, it means 54.5%. 0.545 is 54.5%. Just like 0.643 is 64.3%. Okay? It's a little bit better, but the best way would be just like they did over here on the last one, letter C. It says, hey, 64% of the women and 55% of the men. If you were to round this one up, you would round it to 55. Letter C is, the best way to represent survey results is normally percents, okay? So, sorry that one went a little long. I just wanted to make sure, though, I explained all that and it made a little bit more sense. I hope you guys and gals are doing great. So, have a good day.